Alright guys, this is the second video in our chemical bonds clips. We're going to look at covalent bonds in this clip. So if you have forgotten, a chemical bond is the glue, usually having to do with electrons being shared or borrowed or taken, that holds atoms together. Just like with any glue, some glue is stronger than others. So let's look at covalent bonding. Covalent bonds, all these papers, they get crazy. Covalent bonds are when two valence electrons are shared between two atoms. We're going to look at specifically this one called single covalent bonds. This is where one pair of electrons is shared. So this is our focus. There are ones out there called double and triple bond covalent electrons, and you'll see more of this when you get into high school. So how do they share? How can electrons be shared? So I've got two hydrogen atoms. They both have one valence electron, but their shell can hold up to two valence electrons. So in this picture here, you see that by them coming together, their valence electron is now full, but they have to share these two electrons. Remembering that all atoms want a full outer shell. So this means if their outer shell is the first shell, it can only hold two. So hydrogen and helium both want two in their valence electron shell. The second period can hold up to 8. So all of the elements that are listed on that second row, so lithium and beryllium and boron, carbon, nitrogen, oxygen, and fluorine, they all want to have 8 on their outer shell. Well, lithium only has 1. So he's going to try to bond up with this one of fluorine so that he can have 8. But these two don't really like to bond together. So let's look at one that does like to bond together. We have sodium and chloride. This makes a strong bond. Well, lithium, no, I think it's beryllium. Beryllium and aluminum tend to belong. Aluminum and magnesium try to bond. Our most famous is hydrogen and oxygen. So let's look at what happens when they try to bond. So here I've got fluorine. Fluorine has 7 valence electrons, so it tries to bond up with another fluorine to share that one last spot on its outer shell. So this creates a outer shell completion for both of them. This gives us an electronegativity in its attractiveness. The attraction between the atoms is within the nucleus, like they are attracted to the nucleus. So these electrons on the outside of this green fluorine are actually attracted to the nucleus, the protons, within this red fluorine. This electronegativity causes the atoms to connect to each other and try to stay with one another. So then let's look at the next piece. Some other vocab words. There's lots of vocab words. There's a thing called nonpolar covalent bonds. This is when the electrons that are shared equally within the atoms or between the atoms. So I've got two kids. They're the same strength and they have the same amount of negative charge in them both. So if you think about this as being a cookie, they're both pulling on this cookie equally. So neither one of them really gets it. If they were to break it in half, then they would both get an equal amount of it. So one of our examples here is chlorine. Chlorine combines with itself fairly easily. This one is also in group 17, as was fluorine in the first picture. So chlorine in the blue and chlorine in the orange, they are both going to share this spacing here to create the same strength, so their charges don't change because there's no gain or loss of an electron. They're really kind of sharing it. And the other one is a polar covalent bond. This is when the electrons are not shared equally. One of the atoms has a stronger number or a higher atomic number, so it tends to pull more than the other. This usually has to do with the amount of electrons overall in that specific atom. So one of the atoms ends up with a slightly higher negative charge and the other one ends up with a slightly positive charge. This is not the same thing as the ionic bonding because the electron is still being shared. So the one example that I found that was really easy was hydrogen and chlorine. This is where the hydrogen has 1 valence electron and chlorine has 7. So it shares this little bond here to create, let's get our pen out, to create hydrogen having 2 in its outer shell, which makes it complete, and then chlorine having 8 in its outer shell, which makes it complete. So this is an example of a single polar bonding. So we have the chlorine with a slightly higher negative count because its valence electron numbers are more than the hydrogen, where up here the chlorine and the chlorine are the same. Once I introduce a smaller valence electron number, then the one that's got the smaller ends up losing a little bit of its negativity. An example of a double bond would be water. So we have hydrogen, hydrogen, oxygen. When we write this all the way out, right, H2O, hopefully you remember that. These 2 hydrogens share their bond with the oxygen molecule. The biggest aspect of these covalent bonds is that when they try to break apart, they need energy to pull them apart. So we're going to look at the bottom half of this paper first. So we've got 2 hydrogen atoms, and when they bond together, there's actual energy that's giving off when these covalent bonds are made. In order to break them, I actually have to add some kind of energy transfer. It usually is in the form of heat, and it's high heat, not just I'm boiling water kind of heat. So energy is also needed to break them apart. So these covalent bonds tend to have a little bit stronger connection to each other than the ionic. So last thing before we leave is the ionic bonds from the previous video. This is where one of the electrons is taken. So I've got somebody here with a cupcake and they're like, oh my gosh, yum. And then some other atom or person comes and takes the said cupcake away. Then covalent bonds, we've got a shared electron. So I've got 2 friends. The first person has a cupcake. The second one says, can I have some? So they cut it or share it into smaller pieces. To recap, our periodic table, elements bond by their valence electrons. Atoms strive for a full octet, or 8 in most cases, full outer shell. So how does this help us with our periodic table? I've left off, if you look, group 18 is gone because we're looking at bonding, and the noble gases don't bond with other things. So group 1 is going to love group 17 because this pair usually gives it a great ionic bond. Group 2 and group 16 usually bond to get covalent and ionic. And then I have one of our ways that we get our water is group 2 from group 1 love group 16. So they kind of have to add up to 18 in order to give you a good key of who they're going to bond with. These transition metals, though, they're a little different. Usually their valence electrons vary from 2 to 3 depending on either what row they're on or even what column they're in. So hopefully this is a little helpful. We will spend some time in class playing with some things to look at bonds, and then we're going to start our final review. So see you guys later.